Good morning. You join me today discussing buoyancy, displacement of hulls in water, listing, ballast, among other things nautical, marine based. Another day in the tugboat build, my scale model of the Banbury Cross. Lots to consider now. As seems to be the norm, this is a retrospective of recent tests of the tugboat in various forms in my bath. Think of the bath as just a suitable body of water, sufficient volume to enable me to place the hull and study the buoyancy characteristics of the aluminium construction. In its bare form, the hull was just a shell, sealed fore and aft, but just a shell really, quite wide for its length, this particular model, based on a real life tugboat of the 60s, so I'm okay with the length to width ratio being accurate. I'm okay with that. During the build, I went through periods, as all model builders do, of self-doubt, and although it was built of aluminium, a notoriously lightweight metal, it was still metal. I did go through that phase where I wondered if it would just sink. In the back of our minds, all people of my generation have a passing understanding of physics, various principles of physics, and the displacement when you place an object in water. There's various principles that are the watchword of scientists, but I'm a humble mechie fitter from a shipyard, born in the 50s, worked in engineering from the 60s onwards, so I don't pretend to understand the finer points of the physics. Getting back to the flotation or lack of the bare hull. Lowering it into the bath, it floated. Yep, it floated. Now, any slight deviation in the design, i.e. if the bottom was not perfect in shape, that is, front to back, left to right, width throughout. If there was any difference between the left side and the right hand side of the model, it was going to show up in the first flotation check. Sure enough, being a relatively flat bottom vessel, it did show up there was a tiny list to the left, to the port side, and I can only presume that was a miscalculation in the construction. Now, being a layman, I would just say, well, that can be easily sorted with ballast. But there's forces at work, and there's lots of engineering principles going on, of which I was to learn much more slightly later. Getting back to the bare hull in a bath full of water, I went from would it float to it's floating too well in a split second. I immediately wanted it to sit nice and squat in the water, as did the original real world tugboat, which are notorious for being low in the water, and the Banbury Cross could perform an even squatter squat under load. It would squat down even lower. So seeing my bare hull barely entering the water was a surprise. Pushing down to make it sit lower in the water only met with resistance. And this resistance, as I displaced more and more water by pushing down, made me aware of the staggering concept of how much weight this particular hull could carry. Imagine there's a certain amount of elasticity. When you push down on the inside of the hull, yes, you displace more water and the hull sits slightly lower, but as soon as you release that force, the hull rises up. It's pretty obvious after seeing it and doing it, but this learning curve was very steep. So my immediate thoughts were to make the vessel stable, because it wasn't stable floating so high in the water. To make it stable, I would have to add ballast. Now, bear in mind I did say this was a bare hull. The two prop shafts were placed diagonally through the rear bulkhead up towards the deck area, but there was no deck on at this point, so the prop shafts were just hanging in the air. A later version I put wooden blocks underneath the prop shafts. This reduced the area for placing ballast and made it slightly more difficult to ballast it. It was pretty obvious. Adding ballast would be a case of adding weight equally front and back, fore and aft, port and starboard, left and right of the vessel to keep it level. As I added weight, and this weight included 2 3-2-1 steel blocks. Any engineering personnel will be au fait with 3-2-1 blocks used for marking out on a surface table. So 3-2-1 blocks, a spare bottle of cordial and a massive jug that had contained milk but now contained water. The big jug, 7.2 kilograms it was to weigh. Adding the big jug, the cordial bottle and the 2 steel blocks was a massive amount for my small hull to support, but support it did. Adding this to a working model was going to be a challenge. Removing the bottles and other ballast, I then replaced the deck and superstructure, connected up the prop shaft to the motors for the first bath test. This a major step in the model progress. If you followed the day-by-day progress, you know that all of these parts have been tested individually. Now is the time to see whether the motors had the power to move the vessel in the water, in forward, reverse, and one at a time, to encourage the vessel to turn. Outside of the bath, the motors were hooked up, electronics tested, props spun up, all good. Placed the tugboat in the water and it nearly turned turtle. The extra weight high up, the extra weight being the deck and superstructure and motors, acted like a large pendulum trying to upturn the vessel. that very slight discrepancy at the first bare hull flotation, that discrepancy where the hull did not sit absolutely perfectly horizontal, was amplified with the fitting of the deck and superstructure. It was tempting to try and correct it, but you can imagine, as soon as I released any touch, it listed. Now, it wasn't a sinking, threatening list, but it was a list. And being the fitter that I am, I like to see things straight, level, equal. It's probably OCD of the engineering persuasion. So, ballast it needed. Unscrewing the prop shafts, lifting the front of the deck enabled me to put the large milk jug full of water below the deck into the void that was the hull. Now, this wasn't the full amount of ballast that I'd witnessed earlier. This was just the 7.2 kilograms. But that still seems a massive amount to put in as ballast. It was all slightly forward, but I could live with that discrepancy for now. I just wanted to get stability to test the motors and the thrust power. So, attaching the prop shaft back to the motors, I was able to place the tugboat complete with 7.2 kg of ballast into the bath, and it sat a lot happier. The slight list that it had, I tried to correct by gently placing a 321 block on the superstructure. Wrong decision. As soon as I placed the weight and started to release my touch on the hull, the force of the weight of the 321 block being high up accentuated a pendulum action, and it was about to sink. It was about to rotate about its own fore and aft axis and sink. So, removing the 321 block before it had even really settled, I came to terms with a slight list, telling myself it didn't matter. It did really, but the balance of wanting to test the motors for power, wanted to see whether the props were large enough, wanted to see lots of things, overrode the need to sort out the slight list. The list wasn't going to endanger the vessel. That was okay. So, power on time. Decided to check one motor at a time, and lo and behold, the motor fired up, pushing the stick of the radio control handset, and the tugboat moved forward. In reverse, it was very slow. I put that on a list of to-dos. Sort that out later. Pushing it back to the start of the journey in the bath. Tried the other motor. Success. Pushed it back. Tried both motors together. Success. So, we've got a 29 scale model of the Banbury Cross that moves under radio control power, doesn't leak, and supports lots of ballast. Wow. Time for reflection. Hundreds of jobs outstanding, but actually the project at this moment in time is a success. Everything I wanted, it does. The model is watertight, to scale. It's got the look of the Banbury Cross, and it moves under radio controlled power. So I could stop at this point, but I think I'll continue and refine the model. There's lots I can do to make it look more realistic. I'm notorious for stopping projects when they work. Moving on to another one is tempting. I will put some time in and refine this to the point it's usable. While we're in the middle of this pandemic and I can't get to any large patches of water to give the boat a run out, I might as well refine it. It's got 2.4 gigahertz radio control gear, so it should have a fair range of transmission and receiving. I'd like to see it from a distance to see how realistic I can make it look. I would also like to see it in its natural setting at the River Tees at Teesmouth, with a backdrop of Teesport, where the original Tees towing fleet of Cross tugboats, of which Banbury Cross was my favourite, of which where the tugboats worked. So when lockdown eases and we can travel, I will take the tugboat to the river and mock up some photos, and I will take it to a lake or a reservoir to give it a run out. But viewers, followers, subscribers, fellow boat enthusiasts, the project is a success. Thank you very much to those loyal viewers that have followed me every step of the way. Thank you for supporting me. Your encouragement works wonders. Making these videos really helps me get through these trying times. Let's have a little look at my scale model Banbury Cross moving under its own power for the first time. Thanks for joining me. Join me again soon for more progress on the build.